All right. Here we go, everybody. Let's go. Okay, if you are not subscribed, please subscribe. Come on now. Tell everyone around the world. Let's get some subscribers on the board. There's a free PDF in English y Espanol, so feel free to download that, perform it with someone you love, then come on back and see how you done. Okay, this is Systems of Equations, Graphing, and Equal Values Method, Practice 2. Okay, let's graph these. Remember, whenever you see a systems of equation, that means you're looking for a point of intersection. So I'm going to graph these two lines and find where they intersect. So -1 is my y-intercept, and then I have a slope of down 2 over 5. Down 2 over 5. I'm going to draw that line. I could also go up 2 and over 5 in the other direction, and that would also be a point on the line. All right, so that's important. Okay, let's draw that line. Make it accurate, please. Make it accurate. If it's not accurate, your point of intersection could be off. So make sure you go through those lattice points. Lattice points are points where the grid intersects, right? Okay, now we're going to graph the other line. The other line is also in slope-intercept form. It's got a y-intercept of -8. Notice your number in front of x is a 1. So as a rise over run, it's 1 over 1. So from -8, I'm going to go up 1 over 1. I like to keep applying my slope until I hit the line right there. So to me, that's nice because there's no ambiguity. You know exactly where that point of intersection is going to be. Draw that line, again, all the way through. Arrows on the ends. That's a nice graph right there. And now that point of intersection looks like it's 5, -3. I like to check. Don't want to be off by a little bit and get it wrong. So -2 divided by 5 times your input value of 5. Right? I just input a 5 there. What should I get out? I should get the y value out. -3. Boom. Put your 5 there. -8. -3. We're golden. Moving on. Moving on. Okay. We're going to do it again. We've got two lines we're going to graph. This has a y-intercept of -3 and a slope of down 3 over 2. I can go up 3 and then over 2 in the opposite direction. Just like that. So I can go in both directions on that. Draw that line all the way through, please. Look how accurate that is through those lattice points. That's nice. That's nice. Okay, now I'm going to draw the other line. The other line is in standard form. So I'm going to find the x-intercept by letting y be 0. So if I let y be 0, this goes away. Solve that for x. -18 divided by 9 is -2. That is my x-intercept. Ooh, there's a point of intersection right there. But let's make sure and graph the other one to make sure. This is my y-intercept. Y-intercept has an x value of 0. Divide -18 by 6, you get -3. Hey, that's right there. There's another point of intersection. What's going on here? Oh, I see it. These are the same line. Every x and y is a solution. Every ordered pair is a point of intersection because it intersects everywhere. They're the same line. So that means we have infinite solutions. Okay, not bad. That was money. Okay, here we go. Page 2. We're going to do the same thing. The goal is to find the point of intersection, but now we're going to use algebra to do so. So the goal is still the same. The goal is to find the ordered pair where this line intersects this line. Because y equals that and y equals that, I know that these must also be equal at the point where they intersect. So I'm going to go ahead and set those equal to each other. Now I'm going to solve this equation for x. Add 2x. Add 2x. So I get 9x minus 10 equals 26. add 10, add 10, 9x equals 36, divide by 9, and I get x equals 4. Now to find y, I'm just going to go here, and where I see an x, I'm going to replace it with a vowel. So I have y equals -8 plus 26, y equals 18. Ooh, that's a big number. I'm a little skeptical. So I'm going to check it. I'm going to put a 4 in for my x, and I should get out an 18. Oh, that did work. I'm going to do it on the other one. Put a 4 in for x, and I should get out an 18. Woo, that did work. Let's go. All right, solve the system using the equal values method again. So I take 5/6 x minus 11, set it equal to -2/3 x plus 7, add 2/3 x. Don't let this mess you up. It's all right. Let your calculator have the fun. You can use 1.5, all right, because it's a terminating decimal. But if you got something like this, then you would have to turn it back into a fraction. So, but 1.5, you can absolutely use that number. So 1.5x minus 11 equals 7. I'm going to add 11 to both sides. And then I'm going to divide by 1.5. I think that's going to be 12. It is 12. Okay, now I'm going to go here, and I'm going to substitute that 12 in. Let my calculator have the fun. So I'm literally just going to do the whole thing. -2 divided by 3. Times your input value of 12 plus 7. And I get -1. So my final answer is an ordered pair. Must be an ordered pair form. That's what you're looking for. And that is done. Okay, now we're going to use the equal values method. So I'm going to look at my two equations, and the first thing I notice, it just happens right away, is they already gave me opposites in front of x. So I'm going to bring this equation over and put it underneath this one. And I'm going to add these up. So that goes to 0. That's perfect. We needed one of them to go to 0. Divide both sides by -4. And you get y equals 5. There's y. Boom, it happens just like that. Now I'm going to go here, and where I see a y, I'm going to replace it with 5. So I have 4x plus 25 equals -11. Subtract 25, subtract 25, because we're solving this equation for x. Divide by 4, divide by 4, get x equals -9. That's it. That's done. So, -9, 5. Oh my gosh! You couldn't see any of it. I was doing that work and you could see none of it. That's crazy. Okay, I'm going to let you look at it. Terrible behavior. Terrible. I was so enthralled in my mathematics. All right, so I noticed they were opposites already, so I brought it over. Just brought that straight over. Added up my x's, went to 0. Added those up, divide by -4, boom, there's y. Then I went to this equation. I could have gone to this one. I chose this one just because it was convenient. Put a 5 in for my y, because that's what y equals. Multiplied those together. Subtract that from both sides. Divide by 4. Boom, that gave me x. All right, I hope that made up for my faux pas. By the way, next time you got to tell me, Skirm, you're off the board. You're off the board. All right, here we go. So I'm going to go ahead and check that one as well. Make sure we're good. So I'm going to go here, and I'm going to substitute in that -9 and that 5. So I'm going to do -4 times -9 minus 9 times 5. And notice how I got a -9 out, which I should have. I'm going to do 4 times -9 plus 5 times 5. And I got -11 out, just like I should have. So that works. That is the point of intersection. All right, let's do the last one. Let's hopefully keep this one on the board, so you can see it. Okay. Ooh, I don't have opposites. I can't multiply that by a number to get that. But I can multiply that by a number to get that. So what I notice is, if I multiply this by 2, 2 times 4 is 8. 2 times -3 is -6. And that's the opposite of +6. Equals -24. Don't forget that 2 has to distribute to everything. You want to keep the equation the same. So if I multiply every term by 2, the values x and y will not change. Now I'm going to bring this over. Notice I have opposites in front of my y's now. Add them up. That equals 0. Add them up. Divide by 2. That's it. X is 3. Go here. Substitute in that value of 3 for that x. Multiply these together. Add 30. Divide by 6. Woo, that was nice. 3, 8. All right, that's it. Let's check it. Go to the original equation. Where you see an x, you're going to replace it with 3. Where you see a y, you're going to replace it with 8. And I have to do it to both equations. Okay, so now x is 3. So boom, boom. Y is 8. Boom, boom. Just throw the left-hand side into your calculator. 4 times 3 minus 3 times 8, -12. So this whole thing simplifies to -12 equals -12. That's true. That's all I have to get full credit on the check. Is you got to show me how you substitute in, then you got to show me that final statement. We're going to do it again. We go here. Let's substitute this in. So -10 times that input value of x, 3, plus 6 times the output value y. Notice how that equals 18. So 18 equals 18 is true. Woo! That's it. We's done, my peeps. Good job. Stay strong. Stay focused. Let's get this done. Okay. See you soon. Bye.